Hello students, and welcome to part 2 on my little videos about residual plots. So in part 1, we looked at this data set here, temperature versus sales of soft drinks. So that's the blue dots on this scatter plot here. I did a quick regression, that's this function up here, and I got these orange dots here. Then I did a residual analysis, and I ended up with a plot that looked like this. We decided that because it was random, that meant a linear model was appropriate for this data set. But why? Why does a random scattering of dots mean a linear model is appropriate? And why do other things mean linear is not appropriate? Well, it's best demonstrated with a different data set. So say, for instance, I had this data set here. So the blue dots represent the original data set there. Now, when I'm looking at that, I can see it's clearly not linear. Clearly, it's not linear. But look, I could do a regression. Technology doesn't care. Excel will happily do a regression, as will most scientific and graphics calculators. So if I do a linear regression, it looks like this. Now that's clearly not a good fit, but look, it's done the regression and it's giving me a linear line of best fit. So using that information, I've got a predicted y here. So this first data point, actual minus predicted, well, this is what, about 12, and this is just over 1. So 12 take 1 is going to give me a value of about 11. So as you can see, my residual value here is about 11. Here, this is going to give me a positive residual. This is 6 and a bit, and this is about 2.5. 6 and a bit take 2.5? Yeah, makes sense that it's going to be about 3. So if I do the residual for all of these data points compared to their trend line, it's going to give me these residuals. If I graph my original x values and my residuals, I end up with a residual that looks like this. Clearly, we do not have a random distribution of dots. There's a pattern here. It looks like a parabola. Different to what we had earlier, but still a parabola. So this indicates to me a random distribution of dots is not occurring, so a linear model is not appropriate. This indicates we shouldn't use linear. We should use, a quadratic regression. To give a more complicated example, so here I have, this is my raw data x and y. So it might look random, but if we look at it carefully, we actually have a sine curve here. So it goes up and down and up and down and up and down and up and down forever and ever. I've stopped at 20. So look, again, if I use technology, whether that's Excel or my graphics or scientific calculator, I can get a linear regression. It looks like this. And it's a long straight line, gives me that value. I could sub that in. So here we have a difference of just under 1 to just above 1. So it's a residual of a little under 1, 0.67. Here, a residual of a little bit bigger, 0.75. Here is pretty on the money. As you can see, it's pretty close to 0. If I did all those residuals, these will be negative, these will be positive, these will be negative, these will be positive, these will be negative. I end up with this, and if I graph this data and this data, I end up with this. Again, it's a little bit different to my original data here, but I can see this is not random. It's going up and down and up and down. So because this isn't random, that signals to me, wait a minute, a linear model isn't appropriate for this. I should use something else. In this instance, a sine curve would be more appropriate. So students, that is why linear model tells me this is why a random distribution of dots tells me the linear model is appropriate. Because when I do a line of best fit, I should have half the dots above, half the dots below, and they should be randomly scattered above and below. That's why here they are randomly scattered above and below. Finally, one last hint for those who might be using Excel. Do not ever put a trend line on your residual, okay? One thing that really annoys me when I'm marking assignments is when kids do this. Because why? What is the point of adding a trend line there? What does it tell me? Anyway, students, I hope you found these 2 videos helpful. Once again, please remember to like, subscribe, and click that bell icon.